next step. Can you hear me clear? Great. Thank you very much, BPI, for inviting me as a speaker, and thank Orlando for the opportunity. I'm Haibo Feng. I'm an assistant professor on wood science in forestry. I'm so honored to be here. Next slide. Oh. What's the next slide? The green one, okay. So today I want to talk about the byproduct application opportunities in building construction. So I've been through all the posters, they're all very excellent. Now I want to have a question to the audience. Who is in research in materials? Can you raise your hands? You do research in materials? Okay, who are doing research on building materials? 1, 2. I saw one poster about Mazzillion panels and two posters about the composite panels. Excellent. So that's what I'm going to hear. Today I'm covering the application of bioproduct in building construction. It's a very new area. So since you guys all not in the area, so that's why I'm the right candidate to tell you about the building, especially the environmental impacts, because everybody has to live somewhere. Like right now, we're happening right now, we are in the buildings. So building actually release lots of carbon, as you can see on the figures here. Over 120 megatons of CO2 emission every year, lots of carbon emission from building sector. And then over 40% of carbon emission are coming from the building sector, which is a large portion. These emissions are coming from two parts of the emissions. One is from building operational, and one is from building embodied carbon, operational carbon. So you might ask me, what is operational carbon? What is the embodied carbon? Anybody has ideas? A little bit? Yeah, so next page, I will explain to you understanding the carbon happening in the building sector. So building operational carbon is basically what's happening to run the buildings. The energy used to heat up the waters, to heat up the building, especially in Canada in the winter time, that's mainly used in operational carbon. So the operational carbon reduction has been done, research from 20 years ago. So now it's been really mature from research as well as in the industry. I don't know if you're aware of BC Energy Step Code, which is being fully implemented in BC, as well as going to be implemented in the whole Canada. They're trying to increase the efficiency of buildings on energy performance. So through heat pump, which means instead of using natural gas, we're using more electricity because our electricity is very clean from waters. Or increase the air tightness, which means there's not much air translation exchange, like really seat-tiled, so the energy won't go out from the crackings. Also, the higher thermal properties, the building is getting thicker. By using this method, the operational energy has been reduced dramatically. Now, how about embodied carbon? That's the next stage. What happening is like embodied carbon is manufacturing, transport, and the installation of construction materials. Basically, anything you do to make the materials. I think everybody here, I've been through lots of posters. You're developing all kinds of excellent materials. Also, are you thinking about the energy? Have you think about the raw material you use? Right? The emission happening during your manufacturing, this is all related to embodied carbon. How can we reduce the embodied carbon? Not only in the building sector, or overall. That's something I think everybody has to pay attention, beside our excellent ideas. Okay, what they do in building, right? So, so this embodied carbon is not like just coming out from my research. It's being mandated by the government of Canada many years ago. First one, policy on green procurement, which was initiated on 2006, which is over 20 years. The government level, federal level, trying to promote green procurement, which means promote sustainable materials, not only in construction, in all sectors. That's why we're all sitting here. And also later on, we have coming up with the standards on embodied carbon in construction, which mainly focuses on the building sector. So you see the policy level is being implemented, so which will slowly come into the industry. So that's why in this level, you can see Canadian Green Building Council, they start to making policies by inviting all the people on the national wide to provide suggestions, which was last year they have a summit trying to develop energy carbon, embodied carbon guidelines for the whole country. And the city of Vancouver is always a pioneer on reducing embodied carbons. And they already have the guidelines trying to mandate the building developers to claim their embodied carbon in their material use, which basically will come out to our topics, right? How to reduce embodied carbon. Besides the avoid, which is mainly on building science, probably you're not very interested. Basically, you're using less materials. Maybe instead of a thicker foundation, use a thinner foundation. Instead of concrete pavement, concrete pavement, you use other pavement. Instead of underground parking, you reduce the parking. That would be using avoid. Instead of building a bigger house, building a smaller house to reduce embodied carbon. The other two options, to use alternative materials as well as to decarbonize conventional materials. That's basically what I'm talking about. We can completely apply bioproducts into our building industry to further reduce the embodied carbon. This is not like what I'm saying as an initialization. It's actually happening in industry. Also, that's why I encourage everybody of you guys, if you have excellent ideas, think about a bigger picture, how that can be used in the building sector as well in the larger sector. So the next few slides, I will show you a few really case studies. The first one is the mass timber buildings, timber or trees, right? That's basically one of the biggest bioproducts. I think a lot of us are doing research on bioproducts. You're either using the lignins or the barks, right? In buildings, we're using the lumbers to build buildings. Initially, in Canada, the timber building is very common because we have enormous resources of timber. But nowadays, in terms of higher rises, over 12 floors, initially we used to use concrete or steel to make that kind of buildings. Nowadays, the government, especially British government, are trying to promote timber buildings. Go over 18 floors. I think on UBC campus, we have broad commons, which already prove it is possible. And also, in the government level, we have mass timber action plan, which means the mass timber has to be the first option, especially in government buildings, so which will increase a lot of demand on using timber or bioproducts in building design and construction. Yeah, so this is basically a good picture of the mass timber building project layout in Canada. It's not only one building or two buildings. It's over 850 buildings across Canada that are using mass timber. So it's growing faster and bigger. So that's something I think everybody of us should pay attention. And also, there are over 19 facilities that are manufacturing mass timbers. So that's basically what we do in wood science. Part of our work is trying to promote that and support the industry to have a better transition from traditional construction into mass timber construction. So that's basically the first one, mass timber. And also, for mass timber, you might heard of it. What are mass timber materials, right? CLT, glue lumps, even plywood, all these are like a heavy weight of timber. So by glue lump and CLT, I think we have a course in wood science asking the student to analyze the carbon emission of mass timber manufacturing. And then turns out the glues or adhesives are the major carbon emissions or environmental impact of mass timber. So I'm sure lots of us are doing adhesives. If we can propose a bio-based adhesive and apply it to mass timber, that would be a really good change to the industry. And I'm sure there's a huge industry demand. And I know in European countries, they're already developing this and trying to do the experiment into large scale. So that's one application that is possible for us to think about. The third one is the bio-based composite panels. I think I saw there are two posters talking about composite panels from wood waste, which is awesome. Also, I also encountered a company that's doing timber tiles instead of ceramic tiles. Basically, ceramic tile probably has a higher impact than timber tiles. So instead of using ceramic tile, we can propose timber-based tiles. Same as of the breastboard. I think I'm talking to a lady from NRC. So can anybody guess what is this breastboard made of? Can be made of everything, right? But this one was made of the vegetable residuals. So it's very innovative. This product can be used to replace a drywall or gypsum board, if you're aware of. The gypsum board was basically in the central part was made of basically the plasters, which has a high impact. So if we can apply that into the building instead of a gypsum board, that will help us reduce the environmental impact. So that's another application of bio-based products. And a lot more bio-based insulation. This one has already been applied in PC buildings. It's not new. And I think there are posters talking about this kind of boards. So wood fiber insulation instead of chemical-based insulation, instead of cellulose-based or instead of rigid-based insulation, right? And that one, the hemp insulation, using hemp as the agricultural procedures to create an insulation board instead of a bad insulation, right? And this is a project we've been working on in Abbotsford. And that one, anybody know where it is? It's on campus, university campus, the 3-quadrant. They're using hempcrete and develop a workshop-based house on campus. So it's very innovative and it's been doable as well. It's not new, it makes you think about. The other one is bio-based interiors and materials. That one is the mycelium wall panels, which use mycelium to create decorations. And that one is the wood fiber-based acoustic panels. This one was a building on campus on AREL, just beside the museum, the biodiversity museum. They're using wood fiber for acoustic performance. I think there was a poster there using mycelium for acoustic performance, which is awesome. So you can think about once you finish the product manufacturing or in the lab scale, how can we extend it to the building scale? It's all a big question we should think about together. And for the future next steps, I've been seeing so many excellent ideas. I'm sure professors' lab, there are many other ideas. And in the future, as long as the embodied carbon reduction policy is there, there will be lots of enforcement coming out from upper level to encourage or to force the building developers to reduce embodied carbon, which means you can do so much. If you want to achieve net zero, and bioproduct will be a way to go. That's why if you're interested to expand your project into a real case scale, my lab is doing that kind of analysis, energy performance, thermal property analysis, durabilities. Yeah, please feel free to reach out. Also reach out to BPI for further collaborations. Thank you very much for your time.